Okay, so the last example that I'm going to solve has like 3 transistors. It also has a PNP, so it might be actually quite interesting. So in terms of simplicity, it is actually simpler than the last example that we just solved, but it has more transistors. So looking at this circuit, although I have 3 transistors, what I notice is that the signal is like really the V in, the signal that they have at the V in goes to V out using this transistor. So it's not like really a 3-stage amplifier or anything. It's just a 1-stage amplifier, and the amplifier is common emitter. I can see that because input is connected to the base, output is taken from collector, and it's a common emitter with degeneration because I have some stuff at the emitter, right? Now, what's the point of the other 2 transistors? Most likely I'm going to see them as resistors because, well, of course, in the DC analysis, it's going to be hell, and like good luck with actually analyzing this DC because you have to write a KVL from here to here, and then like basically from here to down here probably. Well, yeah, you didn't have to actually write the top one. So you probably write from V in all the way to here to the ground so that you can actually find this current, and then once you have this current, you find this current because they're related, emitter and collector of a transistor. And then once you have this current, it's an emitter of Q1, so you have the collector of Q1, base of Q1, and etc., etc. But that's not the point of this example. So like in this example, we assume that we have the biasing and everything. We have GM and RPi and everything. We just want to find out what is the gain and what is the, like for example, the input and output impedance of this circuit, right? So we only care about the small signal analysis of this circuit, right? I don't need to, but just because it's the last example, I'm going to draw the small signal circuit. So it's going to look like this. But in the end, I'm not going to use this circuit to actually analyze the gain or the input or the output impedance. So the circuit looks like this. So this is my Q3. So I'm going to call it RPi3. And this is GM V pi 3, this being V pi. Okay. Now, what do I have at the collector side? I have an RC. It's not going to ground. It's going to whatever I see looking up here. What do I see looking up? I see the 1 over GM1. Okay, let's just write it. Plus whatever I have in the base divided by beta plus 1, which is RB2, divided by beta plus 1. And then I'm going to ground. Great. What do I have in the emitter? It's RE plus, again, looking into an emitter of Q2, I have 1 over GM2 plus whatever I have in the base of Q2, which is RB1, divided by beta plus 1. Okay, so just to give you an idea, this is really REQ1, sorry, and this is REQ2. Okay, now what do I have at the base is just Vn. I drew this so that you can see that at the end of the day, this is a very simple common emitter amplifier. It's just that instead of 1 resistor, I have 3 at the collector, and again, instead of one resistor in the emitter, I have 3 at the emitter. So this is V out. Since this is a common emitter with degeneration, I know that the gain is going to be negative GM RC over 1 plus GM RE. Okay, so GM is actually GM3. It's for transistor number 3. RC is all R's or all resistors in Q3 collector, and RE is all resistors in Q3's emitter. Okay, so based on this, I can say that the gain is going to be negative GM3 times, what is RC? It's basically RC plus 1 over GM1 plus RB2 divided by beta plus 1, and the same term, so, this over 1 plus GM3, and now RE, which is RE plus 1 over GM2 plus RB1 over beta plus 1. I wish the naming of this RE and RC was different. So let me actually, for clarity, let's call this RC3 and RE3, so that I can actually, we don't confuse these with the RC and RE that I have up there. So this would be our RC3 and this would be RE3. But this RC and this RE are representing all the resistors in the collector and all the resistors in the emitter of Q3 respectively. Okay, so the idea here is that if it's in PNP, nothing is different, as I mentioned before, in terms of like small signal analysis. If looking into the emitter of an NPN, you see 1 over GM. Looking into the emitter of a PNP, you also see 1 over GM, right? And then, well, the trick that we bring all the base resistors to the emitter by dividing them by beta plus 1 also applies to PNP transistors. So like a circuit might look this complicated, but in reality, it's just a simple common emitter with a couple of extra resistors that if you actually do enough practice questions, you're going to be able to see that. So you really didn't need to actually have this entire small signal circuit to write these equations, because you see, all I did was I knew the equation for the common emitter with degeneration. All I did was that I replaced RC with this RC3 plus whatever I see looking up, which is 1 over GM plus these guys divided by beta plus 1. Looking down, I had RE plus 1 over GM2 plus RB1 divided by beta plus 1. Okay. In terms of input and output resistance, so Rin is going to be, again, because input is at the base, I'm going to have an R pi plus beta plus 1 times whatever I have at the emitter, which is RE3 plus 1 over GM2 plus RB1 divided by beta plus 1. Okay. How about R out? R out is going to be, well, looking up in parallel with looking down. Looking down, because there's no early effect, I'm going to have infinity. So there's no R naught, so this is infinity. So anything in parallel with infinity is going to be itself, right? So it's just going to be whatever I see looking up. So it's going to be RC3 plus 1 over GM1 for Q1 plus RB2 divided by beta plus 1. Okay, so again, I didn't really need to draw any small signal circuit or anything too complicated, or I didn't need to write any KVLs or KCLs. Okay, so the only case that we actually did KVL and KCL in this entire chapter was when we were discussing the first circuit, the most basic circuit for common emitter, common collector, common base. We used KVL and KCL, we found the gain for that circuit, and then every circuit after that, we kind of tried to reduce the circuit or to simplify the circuit to that basic circuit, because we knew the gain of that circuit. We knew the input and output impedance of that circuit, right? So like we tried to simplify everything to that and then try to see like, well, what is the relationship between the two? Sometimes we had to deal with a voltage divider, sometimes even simpler than a voltage divider. I hope it was all clear. Talk to you next week.